Good morning. My name is Polly Sturgeon, and I am the Outreach Coordinator for the Indiana Geological and Water Survey. My pronouns are she and her, and thank you for coming to this webinar. It is just after 11 o'clock on October 21st, 2021. Today is the National Earthquake Drill, known as the Great Shakeout. So I am going to be talking about all things earthquakes and earthquake preparedness for this episode of Dig Deeper. If you haven't watched any of the Dig Deeper episodes before, they are a series of recorded and live webinars that are later posted to the IGWS YouTube page, and each webinar is linked to Indiana state curriculum standards. So if you are able to watch this recording after the live program, you can ask questions in the comments of the YouTube section. The video will also be posted to the IGWS Facebook page, where you can also ask questions in the comments, and I or another geologist will respond to them. Today's webinar, as I said, is going to be focusing on Indiana earthquakes, why they happen, how they happen, and then how to prepare for them. Because in this month of October, always the third Thursday of October, we practice earthquake preparedness. Now, just like any other preparedness technique that you typically learn, you usually learn it in grade school. Think about fire drills or tornado drills. These things that you practice every year as a school child, they become ingrained in you, sort of like muscle memory. And Indiana public schools now all require their students to also participate in earthquake drills. So many students around the state this morning practiced an earthquake drill close to 10 a.m. Some of them scheduled them on other dates, but they will be having them at some point during the school year. I'm going to be showing you later on in this presentation what an earthquake drill looks like and how you can practice it at home. If at any point you have questions during this live webinar, if you were watching it live, you can add them into the chat where I will answer them by the end of the program. But please do keep in mind that this program is being recorded. Okay, I'm going to go ahead and share my screen so that we can get started. Okay. So as I mentioned, I'm going to be talking about earthquakes within Indiana, and particularly the hazards that we have here in the Hoosier State. Today's Dig Deeper presentation will cover the characteristics of earthquakes, why we have earthquakes in the central United States, and some of the more famous occurrences of earthquakes, such as the New Madrid series. I'll talk about Indiana earthquakes more specifically within Indiana, and the different hazards that occur here, and then how to prepare for them. So we'll start with the basics. An earthquake is caused by the sudden release of energy that results when two faults underneath the ground slip past one another, and it produces shaking here on the surface, which we call an earthquake. So there are large, deeply buried cracks within the Earth's crust known as faults, and when each side of that crack or the fault moves, it produces energy that radiates out, sort of like when you drop a pebble in a pond and it sends out those ripple marks. So the earthquake actually starts below the ground in what's called the hypocenter. And then what we more commonly hear of is the epicenter. That's the point directly above where the earthquake happened on the surface of the ground. There are a series of waves that radiate out, known as a P wave or a primary wave, an S wave or a secondary wave, and then a series of surface waves. Here's what each of those waves look like. P waves are recorded on, all of these waves are recorded on seismograph machines, and they make this kind of series of wiggly lines that we see on the readings that seismographs produce. The P waves are typically a very small shaking that are not usually felt. The S waves are what we typically think of when we think of earthquake shaking, and then surface waves are a combination that produces a rolling motion. Now, back in 2017, there was a large earthquake, magnitude 8.0, that occurred in Mexico. And it was recorded on seismograph stations throughout the continental United States, including the seismograph stations in Indiana that you can see here that I'm pointing to with each one of these little dots on the map is a seismograph station. So I'm going to click this star and we can see the waves travel. Oh, looks like it's pulling up over here. Okay, I'll play that back again, but what you're watching, any dot that turns red means that the seismograph is recording an up motion. Any dot that turns blue means that the seismograph is recording a downward motion. So you get the combination up, down, to produce shaking. It's coming from the south because the earthquake originated in Mexico. And you can see how the waves undulate basically through the ground surface of the United States. Let's start that again. Go up, down, all the way through the United States. Now, I like to show that animation for two reasons. One, it really well describes the ground motion that we see as earthquakes radiate throughout the ground surface, where you can see the P waves and the S waves arriving at different times, producing that undulating or rolling ground motion. But it's also a good reminder that earthquakes do not have to occur in Indiana in order for shaking to be felt in Indiana. Now, that particular earthquake, the magnitude 8.0 in Mexico back in September of 2017, no one in Indiana reported feeling shaking from that earthquake, but I will show you earthquakes later on in this presentation that originated outside of Indiana, but were felt by Hoosier residents. Earthquakes are typically measured in one of two ways. We have the measurement of magnitude and the measurement of intensity. These are each different measurements that describe different things about earthquakes. A magnitude measurement measures the amount of energy that's released at the source of the earthquake. And it is determined primarily by those legally line measurements on seismographs. What people commonly know as the Richter scale is the former magnitude measurement scale. It has since been replaced by the moment magnitude scale, which is just slightly more precise, an updated version of the Richter scale, moment magnitude. The scales, both Richter and the current moment magnitude scale, go from 0 to 10. And typically humans can feel anything from about 3.0 and up on the magnitude scale. But it is a release of energy at the source. So it is a qualitative measurement. Comparing and contrasting that to intensity, intensity is a measurement of the strength of shaking that is produced at a particular location. Instead of being a quantitative measurement determined by numerical values, intensity is a qualitative measurement that is determined by human responses based on the effects that they see on their own structures, what they felt, and the objects around them. It is measured on a MMI scale, or the modified Mercalli intensity scale, and that scale goes from 1 to 12, but it uses Roman numerals. Okay, so two different scales. One is numerical based, quantitative, that is magnitude, and is only focused on the one specific location where the earthquake occurred, whereas intensity is a qualitative measurement based on human responses of the shaking felt at different locations. If we look at the just magnitude measurement and the amount of energy that is released, the magnitude scale is logarithmic in nature, meaning that from 1 to 2, it's 10 times more energy. So as you go up on the magnitude scale, it gets increasingly more energy released and therefore more shaking. So if we look at something around a magnitude 3 and 4, that's known as a minor earthquake, it is felt. And it's, if we go up to a magnitude 5, that's around the amount of shaking or the amount of energy that you might feel with the average tornado. If we go up more to the 7 to 8.0 magnitude range, that's known as a major earthquake, where you can get quite a lot of damage happening. You can see some earthquakes that occurred in the United States within that range, magnitude 7 to 8. And that's similar to the energy that was released in the Mount St. Helens eruption. Okay. Going up to the largest earthquake ever recorded on Earth, the 1960 earthquake in Chile, that was a magnitude 9.5. You can see that is more energy than the eruption of Krakatoa, the large volcano. So it's really a logarithmic scale that goes up quite dramatically. And so it's quite a jump to go from, say, a 5.0 earthquake to a 6.0 earthquake. This, in comparison, is the modified Mercalli intensity scale, where you can see, starting with a Roman numeral 1, the perceived shaking is not felt. Going up, say, to a Roman numeral 7, that is known as very strong shaking. We can try to compare magnitude and intensity. It's not a direct one-to-one correlation, but usually a 1 to 3.0 magnitude is going to be not felt. So in that 1 MMI range, compared to a 5.0 magnitude scale, that's usually going to be in this strong to very strong range of the MMI scale. And anything 7.0 or higher on the magnitude scale would be considered a severe or even higher earthquake, depending on the geological conditions that affect shaking. Now, earthquakes occur typically in what is known as the ring of fire. 95% of the earthquakes that happen on this planet occur at the boundaries of tectonic plates, these large black lines that encircle the tectonic plates that make up the surface of the Earth's crust. We call that the ring of fire because typically where those plates melt, they're pushing against each other, rubbing against one another. They're causing earthquakes and also volcanoes. Okay, but Indiana is somewhere right around here, right in the middle of the North American plate. You can see we're very far from the boundary of a tectonic plate. So why do we have earthquakes? Well, it's not as simple as the ring of fire explanation. We have to look back in geologic time. Earthquakes within the central United States, and therefore Indiana, are the result of movement along faults that are very, very deeply buried below the surface. They were formed about 600 million years ago when North America tried to pull itself apart in something called the Real Foot Rift. You can imagine this is a piece of crust of North America. It tried to pull itself apart, creating this weakened area. The rift failed, which is why we don't have an ocean here in North America, but it was later covered and buried. And so those faults, those cracks deep below in the ground still exist, but they're buried by 600 million years of sediment and rock. Here's another view of that. So again, this weakened zone is called the Real Foot Rift that first started forming about 600 million years ago. And it exists in what is now known as the modern Mississippi River Valley. This rift failed. It didn't completely separate the crust of North America, but it created these zones of weaknesses where there's lots of faults. And when those faults move under the ground, we have earthquakes. And because our earthquakes are located inside of a tectonic plate, they are called intraplate earthquakes. Very rare, only about 5% of earthquakes worldwide are intraplate earthquakes. Because they are so deeply buried, they do make it difficult for scientists to make accurate observations. We have to do a lot of remote sensing to understand our faults and their movements. And sometimes we have to wait until the next earthquake happens to even learn about new faults. There are two zones within this weakened area that affect Indiana. The larger New Madrid seismic zone to the south, that is roughly centered around Memphis, Tennessee. And then the Wabash Valley seismic zone here to the north that extends from southwestern Indiana into Illinois and a little bit into Kentucky. Okay, within Indiana, the Wabash Valley seismic zone stretches roughly from Vincennes to Evansville. Okay, there is some disagreement about whether these two seismic zones are related or not. Some scientists think that the New Madrid is controlling the Wabash Valley. Some think it's the other way around. Some think that the Wabash Valley seismic zone is just a northern extension of the New Madrid seismic zone. There's a lot of disagreement, and that's just the result of more scientific studies needing to occur. So something we can determine through future research. Without knowing whether one is controlling the other, what we do know is that both of these seismic zones affect Indiana residents. Both have earthquakes that have occurred in the past where we have felt shaking here in Indiana. So we need to pay attention to them. The most famous series of earthquakes that have occurred within the seismic zones that affect Indiana is known as the series of New Madrid earthquakes that occurred in 1811 and 1812. Now, when you hear New Madrid earthquakes, a lot of times you might think it's just one big earthquake that happened, but it was actually 3 very large earthquakes that happened in a time span of about 3 months. There was a magnitude 7.5 earthquake in December of 1811. In January of 1812, there was about a magnitude 3. And then just a month, not even a month later, February of 1812, there was another magnitude 7.0. Within that time period, there were 4 magnitude 6 to 7.0 earthquakes that were aftershocks of the larger earthquakes. There were over 200 magnitude 4 to 6.0 aftershocks, and then almost 2,000 3 to 4.0 magnitude aftershocks. Just a tremendous amount of earthquakes. Think about 2,000 earthquakes happening in a 3-month time period. People from historical records, we know they thought it was the end of the world, and I wouldn't blame them. I probably would think that too. But it was just a very active time period for the seismic activity occurring in the Wabash Valley and New Madrid seismic zones. During those earthquakes, we had landslides occur, ground ruptures, riverbank failures, meaning that sediment from the sides of riverbanks fell into the river that caused small islands within the Mississippi River to disappear. And we had something called sand blows, where very loose, wet sand, say around a riverbank, got so energized by the shaking, it shot up into the ground. You can see from this map where the epicenter of one of the earthquakes happened down here near the town of New Madrid, Missouri. It uses those Roman numerals from the intensity scale. So it was very strong shaking at the center of the earthquake where the epicenter occurred. You go farther away, you're still getting very strong shaking within Indiana to strong shaking, 6 to 7 on the MMI scale. It was felt as far as Boston, Massachusetts. There are historical newspapers that record church bells ringing from the shaking from the New Madrid earthquakes. This seismic zone that occurs within the central United States, the New Madrid seismic zone, is the most seismically active area east of the Rocky Mountains. There is an asterisk there. It's the most naturally seismically occurring area. There are a lot of earthquakes more recently due to human involvement from hydraulic fracturing happening in Oklahoma. But if we're looking at non-induced or non-man-made earthquakes, the central United States is the most seismically active area, second to California and Alaska within the United States. And we know from geologic evidence that large earthquakes, such as the New Madrid series of earthquakes, have happened before. There were similar sized earthquakes based on geologic evidence in 1450 AD and 900 AD. And that might seem like a lot on a human scale, but in a geologic time period, that was pretty recent. Will it happen again? That's always a question everyone wants to know. And the answer is we can't say. Scientists cannot predict earthquakes, and I don't think that we will ever be able to predict earthquakes, but what we can do is take all of the data and run statistical analyses, and so that we know that we have up to a 45% chance of a magnitude 6.0 or higher occurring again within the next 50 years. If that kind of earthquake were to occur, it would affect between 11 to 12 million people within the central United States and cause over $200 billion in damage. Let's zoom in a little bit. Instead of just talking about the central United States as a region, let's look at Indiana earthquakes more specifically. There have been 44 earthquakes within Indiana's borders since 1817. That averages about one every 4.5 years. They have been concentrated in that Wabash Valley seismic zone, that southwestern portion of the state between roughly Vincennes and Evansville. And you can see on this map, all of those red dots are earthquakes that have occurred in Indiana, and the red lines are faults that we have mapped in Indiana. So most of the red dots, most of the earthquakes, and most of the faults occur down in that southwestern corner. Within the past 200 years, the earthquakes that have occurred here have been between a magnitude 3 and magnitude 4.9. And we'll get to look at some of the more specific recent ones later on in this presentation. If we look at the evidence for ancient earthquakes within Indiana, we know that there have been at least 4 major earthquakes within the past 12,000 years based on geologic evidence. And that geologic evidence has largely come from carbon dating of these structures that are called sand blows. So sand blows happen when that seismic energy, the waves of energy that are radiating under the ground, when they pass through loose, unconsolidated, wet sand, such as a riverbank, and it energizes that soil and makes it shoot up into the air. So you can see this is the structure that's left behind. The soil got so energized, it bursted through the riverbank and it came out of the top. A series of scientists went throughout all of Indiana's rivers down in the Southwest, and they noted where every one of these sand blow features was. They collected plant material that was encased in those sand blows, and they carbon dated that sand material so they could get a date for the earthquake that it was formed from. And each of these black dots are where they collected and were able to carbon date the sand blows. And so they were able to see that there were 4, each of these colors, earthquakes. Down in the southwestern part of the state, there was an earthquake large enough to produce sand blows 12,000 years ago, about 6,000 years ago up here, about somewhere between 4,000 and 8,000 years ago, and another one 4,000 years ago. Here's another view of a sand blow with a little bit more diagrams on top of it. You can see the liquefied sand gets so energized, it pushes its way up to the surface and it comes out onto the top, sometimes called a sand volcano. Basically, the ground behaves like a liquid for a moment in time rather than a solid. And it happens anywhere where the ground surface is less than 30 feet from the surface of the ground, and you have that loose sandy soil. And you see it in earthquakes that are magnitude 5.5 or higher. So any strong to very strong earthquakes. When we look at liquefaction, we know that producing sand blows, we know that it happens in areas with sandy, silty river soils. But another hazard to keep in mind is looking at the effects of geologic materials on shaking. So let's say you don't have liquefaction, but you're feeling shaking that is more intense from your neighbor who lives 5 miles down the road. Well, why is that? That would probably be because you live on different materials. If we take a look at this block diagram in the bottom left, you can see that an earthquake wave traveling through bedrock actually gets bigger when it hits soft soil known as alluvium. That's the kind of soil you find around river banks. Okay, that soil will amplify shaking. It will make the shaking bigger, more intense. And so if you live on a riverbank, you're going to feel more intense shaking than if you live on hard bedrock. We can see a really good example of this in the 1909 earthquake that happened near Terre Haute, Indiana. It was a magnitude 4.7 earthquake. And as you move away from the epicenter, you can see it starts to get less and less intense shaking, which is what you would typically think would occur. The farther away from the earthquake you are, the less intense shaking you'll feel. But as you move away from the earthquake to the south, you can see it goes down in intensity and then it gets back higher in intensity over here by Evansville. Evansville is located along the Ohio River, so it's going to shake more than the neighbors to the north who are located on more bedrock type material. Even as far away as St. Louis, they were feeling the same intensity of shaking, MMI 5, as people in Evansville and surrounding Terre Haute. All because St. Louis is located on the banks of the Mississippi River, so they have that alluvium, that soft river soil. A final thing to keep in mind for the types of earthquakes that occur here in the central United States is that because we are located in this New Madrid seismic zone and the Wabash Valley seismic zone, earthquakes that happen even outside of Indiana, we're going to feel them for a very large distance. And that is because of something called attenuation. Bedrock here in the Midwest is very old. It's cooled down geologically speaking, and it's very, very dense compared to the bedrock that is out in the West Coast, like California and Oregon. Their bedrock is much geologically younger, and it's still kind of cooling down, okay? Which means that when an earthquake happens in California, for example, the waves will lose energy at a much higher rate than earthquakes that occur here in the Midwest. We can look at that graphically here in this image. Here's an earthquake that happened in 1906 in San Francisco. You can see that very quickly the people stopped feeling shaking. By the time you got out of California, maybe a little bit in here into Nevada. You compare that to an earthquake that occurred in 1811, the New Madrid earthquake, similar magnitude to the California earthquake. People, as we mentioned, as far as Boston, Massachusetts, even up into Canada, felt shaking from that. And that is just because of our bedrock is able to carry those waves for a farther distance than the bedrock in the West Coast. All right, if we look at some of our more recent earthquakes that have occurred in Indiana or that we felt in Indiana, we had an earthquake earlier this year in June, on June 17th of 2021, there was a magnitude 3.8 that occurred near Bloomingdale, Indiana. Pretty minor earthquake. It happened in the morning, about mid-morning. Wasn't felt too far, not too intensive shaking. Same magnitude also happened in Albion, Illinois, just across the border from Vincennes area in September of 2017. Another earthquake in 2017 was recorded and felt by Indiana residents just across the border. In 2012, there were two earthquakes before that, both in Indiana, a 3.1 and a 3.0. Then we go back all the way to 2011. So about 10 years ago, there was the magnitude 5.8 earthquake in Mineral, Virginia. It was near Richmond, Virginia, and it was actually recorded being felt in Indiana. Several Indiana residents felt that earthquake. That's the one that cracked the Washington Monument in Washington, D.C. Okay, and the largest earthquake kind of in more recent history, recent memory, was in April of 2008, very early in the morning. There was a magnitude 5.2 in Illinois, just across the border from Vincennes. Here's some photographs from that 2008 earthquake. So again, this was considered a moderate earthquake, felt moderate shaking throughout Indiana, much of Indiana, caused some bricks to fall off of buildings if they were unreinforced bricks, caused some chimneys to cave in, rotated gravestones. So that's what a moderate earthquake damage would look like. Okay. A big question, and we touched on this a little bit earlier, but can we predict the next earthquake? No, and it's unlikely that we'll ever be able to predict for them. This statistical evaluation saying that we have up to a 45% chance of an earthquake magnitude 6.0 or higher happening in the next 50 years. That's about as close to a prediction as we can get, but that's a statistical analysis, not a prediction. If you had an accurate prediction, it would have to have the exact magnitude, the exact depth of the earthquake, the exact time and location, and that's just not possible by scientists. So without predicting the next earthquake, we have to prepare for them because we don't know when they're going to occur. There are 3 very easy things that you can do to prepare for earthquakes, and I bet you have all of these materials already in your home. The first thing to do is to pack a kit. Pack a disaster kit with the materials that you would need to prepare for an earthquake if it were to shut off your water and power for several days. That can happen in moderate to severe earthquakes. Things like non-perishable food and water, a flashlight with extra batteries, because if the power's out, you're not going to be able to charge your cell phone, a first aid kit, maybe a blanket, because earthquakes can happen in any season. Put all of these things into a backpack or a 5-gallon bucket and put it by the back door of your house. I have one of these in a 5-gallon bucket. It's actually at the back door of my house, and it's ready to go in case of the next earthquake, but it's also ready in case there were to be a winter ice storm, a heat wave that knocks out the power, any number of disasters. It's useful for all of those. So you want to pack a kit. You also want to practice the earthquake drill. Again, today is the National Earthquake Drill Day, but you can practice these things anytime. The earthquake drill, what we recommend in the United States to do is to drop, cover, and hold on. When you feel shaking, do not run out of the building. That is probably the worst thing that you can do. If you remember back a few slides, there was that picture of the unreinforced bricks that were falling off of buildings. You don't want to be running outside, get hit by something, or to trip and fall. You want to drop down to your knees as quick as you can, get under something, take cover, like under a table or a chair, and then hold on to it, okay? If you are using a cane, you want to drop down with your cane, and the same thing, get underneath something. If you're using a walker or a wheelchair, lock those wheels, cover your head and your neck, the most important parts of your body, with your hands, and hold on to that yourself, okay? The big thing in earthquakes is protecting yourself from things falling on you. So you want to hold on. Okay, after the earthquake's over, that's when you leave the building and you make sure everything is safe. So that last step, choose an outdoor meeting location, that's what you do after the earthquake. You go outside, you meet in one spot, and you make sure that everybody comes out to that same spot. If they don't meet you there, you know that they might be trapped inside and you need to call for help. It is similar to when you were in grade school and you go outside with your teacher after a fire drill, and that teacher takes attendance to make sure all of the students are accounted for. It's the same principle. You want to pick a place outside of your workplace, outside of your home. So you want to talk to the people that you live with, talk to the people that you work with. Where do we meet outside after something bad happens? It should be the same place for an earthquake, the same place for a fire. That way you don't have to remember more than one thing when the emergency is happening. So you pack a kit, you practice the drill, and you pick a safety spot, somewhere to meet. These 3 things are free to very cheap to do, and they really save lives. Okay. Additional resources, if you're interested in learning about earthquakes or earthquake preparedness, you can go to our website, igws.indiana.edu, and go to /earthquakes, or you can get it from one of the top parts of our website. You go to /earthquakes, and there's lots and lots of information, as well as searchable maps that show you seismographs in real time throughout the central United States, so you can see any kind of shaking that's going on in real time. This was a quick overview, so I'm going to stop sharing here and take any questions. You can put your questions in the chat if you have them, or say them live. Do remember this is being recorded. Okay, I don't see any questions happening in the live chat right now. But remember, if you are watching this recording on our Facebook page or our YouTube page, you can always leave a question in the comments section, and I or another geologist will answer those for you. I will also put links to our earthquake webpage in those comments section, as well as the relevant Indiana state standards that this presentation is covering. They're mostly hitting secondary school standards for 7th grade and some high school standards, but I'll put the specific standards that this presentation covers in the comments of the YouTube link. Thank you, everyone, for joining me for this presentation about Indiana earthquakes and how to prepare for them. I hope that you found it informative, and I hope that you feel more prepared for the next earthquake. Goodbye.